Okay, ladies and gentlemen, this is a very important video. Why is it so important is just because this kind of factoring is always on those state kind of tests. The KC, the SAT, ACT tests, college placement exams. So anyways, this is called the difference of two squares. What does difference of two squares mean? Well, take a look at all four of these problems right here to begin with. Do you notice something similar about all four of them? Pause the video and see if you can see something the same or some pattern. Okay, hopefully you notice that all of them started out with x's, right? All of them started out with x's. What else do you notice? Well, hopefully you noticed if I had a plus 4 over here, I have a minus 4. When I had a plus 7 here, I have a minus 7. When I have a minus 13, then I get a plus 13. And a minus 1 is a plus 1. Okay? So what's my point here is this. If I was to multiply this, you see, this one will end up being x squared minus 4x plus 4x minus 16. Notice 4x and minus 4x make 0, right? So I'm just left with x squared minus 16. Okay? Let's take a look at the next one. If I multiply these two together, I would get x squared minus 7x plus 7x minus 49. Again, notice how in the middle 7 minus 7 is 0. So I'm just left with x squared minus 49. Now pause the video and see if you can't figure out the next two without actually doing the math. Okay, to end the drama here, hopefully on this one right here, you knew it had to be x squared. You knew it had to be a minus. And 13 times 13, okay, is 169. What about the next one? Well, hopefully you realize it was x squared. And then it was also a minus 1. Okay, so if you understand this pattern, let's put it to good use. Can you factor this right here? X squared minus 25. Well, hopefully you realize it's got to be x times x, and 5 times 5 is this 25, and all I need is one of them to be a plus and one of them to be a minus, and I just factored the problem. Okay, let's take a look at the next one. Notice again I have an x squared and I have a 81. Both of them again are perfect squares. Okay, x squared is x squared and 81 is 9 squared. Long story short, isn't this going to be x times x? 9 times 9 plus 9 minus 9. Let's try the next one. Hopefully you got x times x. What's 4? 2 times 2. One's going to be a plus. One's going to be a minus. Now for the grand finale. Pause the video and think about this problem for a minute. Okay, so hopefully you realized that 9x squared is really 3x times another 3x. It's 3x squared, right? And 36 is really 6 times 6, or 6 squared. Since we have a square minus a square, we call this the difference of two squares. Hence the name difference of two squares. So what's the grand answer? It's simply 3x times 3x. Again, that makes my 9x squared up here. And 6 times 6 will make my 36. And one has to be a plus, and one has to be a minus. Now, we stumbled actually upon something else. Stay with me, we're not quite done. Did you guys notice that we have a 3 and a 6, and a 3 and a 6, and all those numbers I can divide by 3? So couldn't I say it's 3 times x plus 2 here, and 3 times x minus 2 there? So my real final answer is going to be 9. 3 times 3 is 9. What happened there? 3 times 3 is 9. And of course, I have x plus 2 times x minus 2. Please watch this video more than once, okay? Soak in every bit of information. If you're avid, I imagine you can make at least 2 pages of Cornell notes, okay? But anyways, I'll see you in class tomorrow, and we will be doing some more factoring. Until then, bye.